Hi, we are Sebastian Ravanelli and Nicola Sallusci, two students attending the second year of the Aldini Valeriani Technical Institute in Bologna. Our institute is multicultural, and this is an advantage because the circulation of different ways of thinking leads to cultural enrichment. In this project, we will talk about radioactivity and radiotoxicity, going so far as to expose a modern example of experimentation concerning nuclear energy. Radioactivity is the phenomenon whereby the unstable atoms of some elements transform themselves, or they decay spontaneously in other emitting particles. These particles are radiations. Radioactivity is a natural process. The French physicist Henri Becquerel described it. He observed that some minerals containing uranium and radium had the property of impressing photographic plates placed in their vicinity. The plates, once developed, had spots. Because of this property, elements such as uranium, radium, and polonium were called active, and the phenomenon was called radioactivity. These elements are called radionuclides. The radiotoxicity of a radionuclide is the potential ability to induce harmful effects on living tissues following its incorporation. The radiotoxicity assumes different values for the various nuclides, depending on the nature and energy of the radiations emitted, the periods of physical and biological half-life, and the radiosensitivity of the organ of interest. It's interesting to note that biological damage does not only depend on the amount of energy deposited, but above all on its nature. For example, in medicine, radioactive elements are used for diagnostic purposes, like radiography. In this case, the radiotoxicity of the elements used is weak, and therefore no damage is found in the organism. Very different are the effects of highly radioactive elements, such as those used to produce nuclear energy through fission, such as uranium. Since the fission process is very dangerous in the event of breakdowns or losses in nuclear power plants, research regarding the nuclear fusion process has greatly developed in recent years. Among the various research projects, the most ambitious currently is the international ITER project. The ITER project aims to develop an experimental reactor capable of sustaining a nuclear fusion reaction for several minutes. Using fusion, the power plant will produce non-radioactive waste, as it uses elements such as deuterium and tritium, isotopes of hydrogen, therefore not radioactive by nature. We think the ITER project is very cost-effective. Using fusion instead of fission, the risk of damage to organisms and the environment are much lower. Waste, being not radioactive, can be disposed better than the ones on fission. Hoping for a rapid development of scientific research, we thank you for your attention.